What are these? The female cones, be more specific, please. Ovulate cones, and their function is to produce ovules. Like this here. That's also a female cone. That is truly a seed cone. These here are about anywhere from 18 to 24 months younger than those. So there has been a developmental sequence here. These have already liberated their seed. You can see they're in a woody condition and the scales are completely spread apart. These are fleshy. The scales are spread apart for receiving pollen. And in between the two is a stage in which the scales are all compressed and the ovules are developing on the inside of the cone. So here is female cone. Here's a female cone close up. You're looking at a single scale. There's one ovule, and there's the other one. You look at the top of the scale. The micropiles open up back towards the central axis of the cone, which would have been right here when they peeled that scale off. So a couple of ovules on the top side there. Here you're looking at it microscopically. The female cone, there's the central axis of the cone. You can see here is the scale. This is called a bract. Okay. And I can't see much else, but if we look at this one, we get a better idea. Oh, there's the bract. There's the scale. Here's the micropilar arms. There's the micropile. And this is not yet occurring, but the female gametophyte will develop right in this area when it develops. This is the single cell right there that's going to give rise ultimately to the female gametophyte, not yet developed. All right, here's that same picture again with pollen grains have been drawn in. Here is the integuments. This layer right here, you'll see it more developed in a bit in a developed ovule. That's the nucellus, and the pollen grains are being pulled in. They'll touch the surface of the nucellus, and that will induce germination. Now you are looking at a mature ovule with a mature female gametophyte. And you can see the integuments on the outside. There they are. You can see this layer right here. It goes all the way around. Comes right through here. That's the nucellus. Both of those are diploid layers. All of this stuff in here is female gametophyte. It is haploid. You see two archegonia down here. There's one archegonium and there's the other. This is the micropilar end of the ovule. All the rest of this spongy stuff in here is albumin, which is part of the megagametophyte. It's the nutritive part of the female gametophyte. Looking at it in close again, integument, nucellus. Right here on that boundary is where the female gametophyte starts. Most of it's albumin, stretching back this way, but you do have an archegonium there, developing egg on the inside of the archegonium. When the pollen grain comes in, it will touch the surface of the nucellus. The tube's only got to grow from there to there. Short distance, but again, sluggish growth of those pollen tubes. There's one. Pollen tube trying to make its way to an archegonium. Can't see the grain, it must be right out here somewhere. You can see that this pollen tube has made it through most of the nucellus. It's just starting to get into the female gametophyte right there. Here is an archegonium. There's the boundary of the archegonium right there. There's the egg with a single nucleus in it, so developed egg. Looks like there's another archegonium over here just out of the planar section. Oh, I do have a picture of it. When this egg gets fertilized, there will be an embryo there. Okay. What will happen before the embryo develops, you will get some cell division and it will produce these really, really long, wispy cells. There they are right here that have embryonic initials on their ends. These wispy cells, as they elongate, push these embryos out into the albumin. Okay. And so the embryos can absorb this nutritive tissue, and that's going to fuel their development. Here is a seed, iconic seed. Here's the seed coat that developed from the integument and nucellus. Here's the embryonic plant. And there is the albumin and this white crystalline stuff. So help me with the ploidies here. Ploidy of this is 2N. Ploidy of all this spongy white stuff It's haploid, it's called albumin, it's nutritive tissue. Then you have 2N again. This is the 2N of the embryo. The 2N that's out here came from the nucellus and the integuments, and the 2N that's in here are the diploid states of 2 different generations of plants, the parents and the offspring, with a gametophyte wedged in between them. That's that white stuff right there. So they are both 2N, but they are not of the same origin. They're 2 different sporophytic generations. That's the key thing to know. With a gametophyte generation sandwiched in between them. White. All right. You will also look at the zamiacete. It shows you a bit of additional detail on the embryo. This is the embryo again. It will correspond to what you're seeing in yellow here. Here's the embryo of zamia. You can see a little detail. This is called the hypocaudal down here. There's the epicaudal, which is the top part of the shoot, and these are the cotyledons. The cotyledons help absorb the albumin, which is around the developing embryo. The seed coat's been removed in this particular section. So this is just another view, basically, of what we saw here macroscopically, a microscopic view. It's a different species. This is zamia, and this one was from the pine. All right. Oh, this one does have the seed coat. Seed coat there, albumin out here, embryo in there, cotyledons there. All right. Let me show you the pine life cycle.